Well, would you look at what we have here? A 1994 Jaguar X16. It was towed here because it doesn't start. It's been sitting for some time in a garage in storage, but it was running several months ago. I believe it's a 94, yeah, R is 94. I just offloaded it off the trailer. He's got a brake pedal applicator. I gotta take this out of the way. So initially he said it was a crank no start, and then he left it sitting for another month or so, and now it's a no crank condition. It's in park. Turn the key on, I hear something power up. I'm not sure if that's a fuel pump, but there's no dash lights. This has got the mechanical lockout, so if you turn the key to crank once, you can't turn it a second time without turning it off. There's power. Let's try the headlights. That's interesting. The hazards are flashing, but no hazard indicator on the dash. Well, I'm going to check a few things. So I got the ignition in the run position. Turn signals don't work. Let's try the wipers. No wipers. Well, I know he's had the battery out of this thing, so let's make sure there's no wires left disconnected at the battery. So the battery cables were loose, but not loose enough to cause a problem. Obviously the horn worked. I don't see any wires left disconnected here other than this one, and it might be for light underneath here or something, but nothing serious anyways. I'm going to look at a power distribution diagram and see where the power flows. There's got to be a main junction box. I'm going to open the hood and have a look under the hood too as well. So there are 5 power distribution diagrams on this thing, and it shows the positive battery cable going to a right terminal port. I don't know where that is, obviously on the right side, but it feeds most of the fuses that are hot all the time in the right fuse box, which is right at the right A pillar. So I went to the right A pillar and I started checking fuses in there, and I found one fuse that is blown, and that happens to be for the fuel pump and the ignition coil. So that's probably why it was a crank no start with no spark, but that doesn't explain why it's a no crank condition now. I did find the ground cable at the battery going to the body was finger tight, so I tightened that, but that didn't make any difference. There are 3 fuse panels. There's one on the right A pillar, one on the left A pillar, and one in the console. So I printed all these diagrams. I'm going to change that 10 amp fuse and see if it blows. It was a 10 amp fuse. I'm not sure which one it is, fuse. I'll look at it in the fuse panel. So this is the right fuse panel, and A1 fuse is live, so that means the feed stud has got power to it and it's feeding into this fuse. But this one over here, this 4th one down, is live on that side, but not that side. And according to this, that 10 amp fuel pump coil and lambda heaters, oxygen sensor heaters. So we're going to replace that, but I'm sure that's not going to fix the no crank condition. And we're going to investigate whether, yeah, it's blown. Did I bring a fuse in here? I carried some fuses with me. What the hell did they put them? Oh, here they are. So far every fuse on this side has got power to it, and I don't have the key on. Well, I'm going to check the rest of the fuses here. I need two hands. So this second 25 amp fuse is blown as well, and that's for the fuel pump according to the information there. But again, that shouldn't affect the no crank condition. This thing's probably going to need a fuel pump because it's been sitting. It's hard to see out here with the sun in my peripheral vision. Okay, so that 25 is burnt. Well, I'll replace it too, but I don't think that's going to fix the no crank condition. So there's the fuse panel on the left A-pillar. Every fuse at that fuse panel is powered up on both sides with the key off. So that eliminates a bunch of things. Now, we did find two burnt fuses on the other side, but they should not result in no ignition and a no crank, in my opinion. So I'm going to study this schematic and see if I can figure out where to go next. So there's the third fuse panel under the armrest. They're all 5 amp fuses and they're all dead, even with the key on, but then the ignition is not functioning. So let's have a look at this wiring diagram and see where the ignition switch gets its power from. Maybe there's a main relay that needs to turn on. I'm having difficulty finding a schematic showing the actual ignition switch, so I thought I'd go to the starter circuit. Now it says the starter relay is under the right side of the dash, and it gets power from fuse 6 in that central fuse panel, that one of those 5 amp fuses, and it says hot in start, but it doesn't show where that comes from. That relay is ground side controlled, provided it's in park or neutral, and by the central microprocessor behind the glove box. But I'm sure that that's not waking up because the ignition switch is not, it's not seeing the ignition. I did find reference made to an ignition relay, but I can't find the ignition relay. I'm going to look at all data diagrams. So here is the OE version of the schematic, and it shows the ignition switch. And the ignition switch is an input to the central microprocessor. Looks like the switch just has multiple switches pulling down. So the microprocessor must control that ignition relay. Wow. So I'm going to go back to the Mitchell diagrams and look at the microprocessor, because this one's not that convenient to understand. There's the starter relay on the right hand side. Starter inhibit relay. Key interlock relay. Well, I can look around. So I remembered I had a DVD version of all data that went up to about 2010. So ignition relay location. Cooling fan relay, front accessory relay, ABS main relay, ignition on relay, which is right in the middle of the dash. I wish I could find a diagram for it. I'm going to look for a diagram, see how it's wired, see how it's controlled. But this diagram shows, it doesn't show the ignition on relay. It shows the ignition switch or a portion of it, but it doesn't show the ignition on relay. But it calls that a starter relay. Focus. Starter relay logic. Well, that is for the starter relay because the starter relay is over to the right. I'm going to look on this schematic system, see if I can find the diagram for the diagrams, electrical diagrams, ignition switch, up to VIN number, below, after VIN number. I guess I got to find out what the VIN number is. So this is the only diagram I can find showing that ignition on relay. And it's to the left of these 3 relays. You can see these big main relays in here. One's blue, one's red, one's yellow. So this one is blue, this one's red, this one's yellow. Over here, yellow. But the ignition on relay says the black connector, and it says light blue. I don't know what that means, but I can't find it. This is just clipped up here. These are actually labeled auxiliary, positive, side light, positive. The schematic shows several versions of the diagrams depending on what VIN number it is. And we already established we have the late VIN number. So there's the ignition on relay, but it doesn't show how it's controlled. It just shows power coming in. Well, I'm hot on the trail. So according to Google, the relay is a standard 4-pin relay. Now it does show a clamping diode across it if I'm not mistaken in the schematic, but it's a standard 4-pin relay. So I was reading some Jaguar forums and I come across a thread where somebody mentions the inertia switch, driver's side left footwell. And I thought, I wonder if that's tripped. So I went out to the car, I'll show you what I found. So the inertia switch lives under here, right up in there, and it has a rubber cap on it. I pushed up on the cap, although I didn't feel the switch change state. The cap is facing down. Now when I turn the key on, I have gauges and warning lights. And the vehicle attempts to crank, but then stops cranking. It did crank initially, and I'm wondering if those fuses burnt over there. Well, I'm going to check those 2 fuses that were burnt before. So all of those fuses test good. Now it's acting like the starter relay is malfunctioning. You can hear the starter engaging, but it's not cranking. I can't remember if it made an attempt to crank the first time or not. I think I hear the fuel pump running. Well, let's find the starter relay and bypass it. So according to the schematic, the starter relay is under the right dash. It's in one of those boxes. I printed the wiring diagram. Now that center fuse panel, fuse 6, is powered up during crank. So let's see if we can find the starter relay and bypass it. So it's G4 in this relay module. This one here, I wonder if this cover comes off. So I don't know if this is an integrated relay or if this cover comes off. It's the blue one towards the driver's door, but it says door unlock, door lock, mirror, heaters, and starter solenoid. So it's like there's 4 relays in this integrated housing, but I can't figure out how to get this stupid thing off the mount. So I took it apart, and it's not it's 4 relays, but they're integrated into a circuit board. I could figure out which one it is. I'm going to plug it in, see which one activates. So this one right here activates. I think the battery's too low. So the ECU was shutting down because the battery was too low. I put a booster battery on it, now it cranks. Let's see if those fuses burnt again. Was this 10 amp one? That's good. And this 4th 25 amp one. So that's good. So now we got to check for spark. We're making headway. Let's put this relay center back together. So I got a spark tester on number 1 plug wire set at 20,000 volts, and I got a trouble light or 194 marker bulb connected to the negative side of the coil and ground. And when I turn the key on, that light should come on and stay on, and when I crank it, it should flash. And it's not flashing, and I've got no spark. So I'm going to check to see if we got injector pulse. So I got the key in the run position, and I got a test light connected to ground, and I got power on one side. I got power on both sides because these are probably sequential or non-sequentially injected. But we have power there, so now let's see if we got a flashing Noid light. Make sure I got it plugged in. Contact. So we got no spark and no injector pulse, which leads me to believe that we're missing a reference signal. I never paid attention to see whether the tach works in the dash, but it does indicate RPM if we trust it. Now, the diagnostic connector is in the trunk, but I don't think this thing supports anything more than flash code diagnosis. And I don't have the ability to scan it. But we're going to have to figure something out. We're missing injector pulse and spark. Oh well. So I'm looking at the ECM controls, trying to figure out where the crank sensor is and what kind of crank sensor it is. Don't see it on that page. Fuel injectors are batch fired, like I suspected given the vintage. Maybe it's on diagram number 2. Crankshaft sensor. So it's got 3 wires to it, but one wire is a shield, so maybe it's just a magnetic pulse with a shield on it. So there's one. Goes to location 12, and the other one goes to location 15. On the previous diagram. 12 and 15. and nothing's labeled. If it was labeled CKP plus or CKP reference voltage or something like that, I'd know whether it's a Hall effect, but I doubt it's a Hall effect given the vintage. Let me see if I've got component level testing, and I don't have the vehicle selection, but I might be able to do component level testing. It might tell me what type of crank sensor it is. It's worth a shot. 94 XJ6. What's the difference between an XJ6 and an XJ6 Sovereign and VDP? Well, it's a 4-liter. Yes, I want to load that. Engine, crank sensor, component information. Magnetic pulse generator sends an AC voltage signal to the ACM. Above the crankshaft pulley at the front of the engine. Connector harness is nylon tied at the front timing cover. So, I guess a visual inspection is in order to begin with. So I'm going to do that. So the sensor is just above the harmonic balancer, and the wiring is molded and comes up to here. It looks like it's been repaired at one time. There's some tape or loom or something. It could be a factory, but anyways, to detect the signal go across the sensor and with a graphing multimeter, lab scope. So we'll see if we got a signal. So let's see if we got a signal. I have to replay my video to see if we had a signal. So I replayed the video and I didn't see a signal, and I checked it several times now and I don't see an AC signal. I'm going to disconnect the sensor and check continuity through the sensor. It could be that I'm making a connection with my back pins too. So the amplitude was set incorrectly. It was set to 50 volts AC or 50 volts DC. So but now I've got the sensor unplugged and I'm across the 2 pins on the sensor. So I'm going to plug it back in with the same setup and make sure that, because if the wires on the way to the ECM are shorted to ground, that would cause a loss of signal. Like I said, the amplitude of the meter was set at 50 volts. Now I got it at 5 volts. So we got a reference sensor signal going into the PCM or ACM, but no injector pulse. There's no cam sensor on this as far as I can tell according to the information. It just uses that sync pulse off the crank because it's got a distributor, so the distributor distributes a spark to the appropriate plug, and the injectors are batch fired, so it really doesn't need a cam sensor. I wonder if we can get some kind of diagnostic flash codes out of this thing. So I started thinking last night about this crank sensor amplitude, and I'm wondering if it's too low to be recognized. Remember, I had to adjust the amplitude of the multimeter. Now that's not uncommon for Snap-on's guided component test to not be 100% accurate. We do have a signal coming out of it, but it may not be high enough amplitude to be counted. So I thought I'd try an old school trick where you use it's a magnetic pulse generator, so you use an electric soldering iron. I've got the key on, and I'm putting this soldering gun next to the crank sensor, and when I press the button, you can hear it. The ECM picks up a reference. and runs the fuel injection, it runs the fuel pump. So I'm leaning towards a failed crank sensor, which seems to be fairly common. I'm going to test the crank sensor's resistance, although that's not a very accurate test. So before, when I was testing this, I didn't notice the fuel pump ran after it started cranking. You can hear the fuel pump prime when I turn the key on. I'm going to turn the key on. And then when I crank it and release the key, the fuel pump is running. So theoretically, it's getting a reference pulse. Now, there was comments in the forum that I read about if the battery voltage is too low, it may not fire the injectors, or it may not attempt to start. Now, I do have a booster battery on it, but I'm going to put a battery charger on it and set the voltage a little higher. Okay, so I have a booster charger on it, and that should elevate the voltage. I got a Noid light on number 3 injector, I think, and a spark tester on the coil wire. It's cranking faster, but it's not recognizing it. Can't see the Noid light through the windshield. So I'm gonna test powers and grounds to that ECM. So I'm checking the main feeds here. That white wire on the blue connector in pin 10 is ignition power from that EMS relay. And that's live. Pin 11 next to it is a ground. But pin 14, which is this corner pin right here, is supposed to be battery power. But it doesn't show where it comes from. It says it's 14, FEO 40-14 input battery power. And I don't have power on that pin. Now it says it's, doesn't say what color the wire is. NB. But that's 14. 15 is orange yellow. Unless they count them from this end. Yes, they do. So this snap-on information is not completely correct because it shows, oh no, it is 1 and 14. I couldn't read it. Got to put my glasses on. So pin 14 is live all the time. So I'm going to check the voltage drops on the grounds. So I got a 1156 or 3057 bulb connected with both filaments to the feed stud underneath the hood, and I'm using pin 11, which is the one next to the power, and it lights up that bulb quite brightly. And then pins 23 and 24, which is these two pins here, 23, 24 and 23. So those are good. Those are the main grounds. These two black wires. This is a fuel injector control wire, and that's a fuel injector control wire. So it's starting to look like the ECM has failed. Wonder if we can get a number off of this thing. There's a number right here. I might unbolt it from the under the dash area. I should actually check the voltage drop while it's cranking, compare it to battery negative post. Well, now that I know which wire is which on here, I was trying to figure it out. I'm going to unbolt that ECM. So there's the ECU out. Lucas, Prince of Darkness. Doesn't smell burnt, but anything could have happened, boosting this thing or connecting the battery with the key on or anything. So we're going to measure powers and grounds while it's cranking. Now that I know that this white wire is coming from the EMS relay, and this brown wire is coming from the EMS relay. Or no, sorry, this white wire. Yeah, this white wire here is coming from the EMS relay. So I got a jumper wire running to the battery negative post in the trunk, and my voltmeter connected up, reading millivolts on the ground on pin 11, I think that is. Yes, pin 11, and I'm going to crank it. 250 millivolts, 0.2 volts, so that's okay. Let's try this one. Turn my light on here. Okay, that's pin 24. $260 millivolts. And pin 23. $260 millivolts. Let's make sure we don't lose ignition power on pin 1 here. This is ignition power. Now I gotta put this on volts. It's a little low. I'm going to check the voltage drop on it. I got to see if my battery charger shut off. Let's repeat that step. This is coming from the EMS relay. I better check voltage drop on the circuit. I'm going to move the ground wire over to the positive battery post. So now I'm going positive to positive. 0.13 volts. That's quite a bit. 0.7 volt drop on that positive wire. Wonder if we got it on the same other circuit. Pin 10 on this wire is coming from that EMS relay as well. Hmm, 0.7 volt drop. Wonder if that EMS relay is creating a problem. I believe this is the EMS relay here. It's actually warm. Wonder what this relay is next to it. Same part number. One of these is the AC clutch relay, or the O2 sensor relay. These are pretty oxidized. Let's try switching this relay. Holy smokes, I got 2 volts drop from that relay. Let me check what that relay is I put in there. So that relay that I swapped in for the EMS relay was the AC clutch relay, and it's actually a different part number. So I've got the EMS relay bypassed with a jumper on pin 30 and 87. We still got 0.7 volt drop on that positive circuit. So I bypassed the power to pin 30 and I jumped pin 87 directly to the feed stud, the boost stud, and I'm going to crank it and see what it goes to. How is that possible? So now I got the voltmeter connected to the boost stud. Key on with no current flow, it's 0.05. So relative to the negative post of the battery, I got 0.7 volts drop. I wonder if that boost stud needs to be cleaned. Oh boy. So this is where I'm talking about the boost stud here. And I just pulled on this cable and it's fucking loose. Excuse the language. Now that's just going to an insulated stud on the firewall. So it's just for boosting purposes. There's no power coming off of there, but where does that go? In behind to the starter maybe. So I tried hooking my booster battery up to the power boosting stud here and the engine block, and I still got a test light across the negative side of the coil and a spark tester on the coil wire, and it makes no difference. Now I do have about 0.5 to 0.7 volt drop on that EMS power ignition 1 wire, but I put direct power to the ECM from a 12 volt battery and it doesn't make any difference. So I'm leaning towards the ECM is not responding. I'm not 100% certain on that crank sensor, although the crank sensor generates a pulse enough to move the tach, if that counts. You can see the tach move, and I've read all kinds of mixed things in the forums about whether the tach should actually work or if it comes off of the ignition. Watch it when I crank it. And it's cranking fast enough in my opinion. I suppose we could check for a reference signal right down at the ECM. I think it was pins 13 and I can't remember. I have to check. It's in the yellow connector anyways because it's a sensor. Yeah, maybe I'll do that for what it's going to take. I checked for a crank sensor last night just for the hell of it, and it's $300+ on Rock Auto. Not available from any suppliers locally. I can even cross the NTK part number and doesn't exist in Canada at least. And it's not like I can go to the salvage yard and just get a spare crank sensor. I wish I had a simulator and I could simulate a crank signal and see if the ECM responds to it. But it's 36 minus 1 like a Ford. Yeah. So I thought I'd try flagship 1 for remanufactured ECM. Not even listed. Oh well, let's look around. So there's the resistance measured across pins 24 and 13 in the yellow connector. The red and blue wire which come from the crank sensor. And it reads 1.29 kilo ohms, and the spec according to Snappy is 1.4 to 1.45, so it is a bit low. I got the same amplitude of a signal here as I do at the sensor itself. I checked for the availability of a used ECM. There is one in Southern Ontario I can get for around $300, but it's a crapshoot. I'm not convinced, but I gotta start throwing parts at this thing at some point. Pick your poison, crank sensor or ECM, because they're both about the same money. And that's a used ECM, obviously. So I got the meter set up to read AC voltage across the crank sensor blue and red connect pin. And typically it's got to produce at least a half a volt AC at the lowest speed it'd be expected to be recognized, which would be cranking speed. So I think that the testing procedure in the Snap-on scanner here, Snap-on component level test, has got the voltage amplitude set at 50 volts BC for cranking test, and the same amplitude at a running test. And obviously a magnetic pulse generator produces a higher voltage at a higher RPM. So I think that's wrong, and I think the crank sensor is good. I've tested it with the resistance. It's slightly lower, but then it's cold. It's not at operating temperature, and it doesn't specify whether that's hot or cold. So I'm leaning towards an ECM here. So I got the lab scope connected to one of the injector drive circuits. Again, I assumed I had no injector pulse because the Noid light wasn't flashing, but watch what happens. I do have injector pulse, so we got a no spark condition. Damn. So this uses an igniter or ignition control module, which receives a signal from the ECM on this white red wire, pin 7 on the module, but it's pin FE40-1. So I'm going to check that signal. I double checked to make sure the coil was plugged in or connected correctly, because I see he's changed the coil or has a used coil on the floor here. And I got 12 volts to the coil because that light is on. So let's check this signal wire. I'm checking it right here at the ECM. I'm already in here, so might as well. So I'm about to crank it and look for a signal on that white red wire. So you can see there's a signal there. So that igniter has failed. I'm going to check the power wire to it. So this is the white red wire that I just tested at the computer. And this other white red wire is the power feed to this thing. And the white black wire goes to the negative side of the coil, and it's not triggering it. So I'm going to qualify that I got power on this white red wire with a test light. Key is on. So I got the test lead of a 500 milliamp bulb connected to the ignition feed to this igniter and the body. And I'm sure that this one will have power too, because that comes from the negative side of the coil. Oh, I'm going across the coil. I should have been on ground. So we're going to get an ignition control unit. I tried a 194 bulb across the injector, and it didn't flash the 194 bulb. It may be that the test light bulb is too high a wattage to note flashing. Unrealistic, unbelievable. So the Napa part number is a TP473. The standard motor products part number is a LS973, I think. LX973. Rock Auto doesn't have it in stock. Napa doesn't have it in stock. Auto Parts Central doesn't have it in stock. Nowhere in Canada. But I mean, Rock Auto doesn't even have it. I searched on Amazon and I can't find it. Go figure. Wonder if we could make something else work. I don't know if that's just a 5-volt pulse. I didn't take a look at the amplitude of the voltage coming from that. It's like a transistorized ignition coil control circuit on a Chevy. But I mean, realistically, we need this part, LX973. So I connected an LED across the injector, observing the correct polarity. And you see when you turn the key on, you actually get a... And when you crank it, I'll zoom in a little bit. Let's turn it off. It's hard to see out here in the sunlight. I'm not sure the camera's picking up the flashing LED, but it is flashing. So we had injector pulse all along, and the Noid light just didn't work, and then 194 bulb didn't work. But the lab scope picked up injector pulse, so thank goodness I checked that. I assumed that we had a more serious problem because I thought we were missing injector pulse and spark, but it's just spark we're missing. I don't smell fuel though. That's bothersome, because normally with this much cranking there should be fuel odor. There's no fuel pressure test port on this thing to check fuel pressure. This is the fuel line coming in. And there's a fuel pressure regulator. Oh, I'm zoomed in. So this is a fuel line coming in. There's a fuel pressure regulator. The fuel rail. No pressure test port. They could have put one right here. It would have been so convenient. And this is a return line. I can hear the fuel pump running, but that doesn't mean we have fuel pressure. So I'm just curious as to whether this tach works with a missing crank signal or not. So I unplugged the crank sensor. Fuel pump ran. So the tach doesn't register RPM if there's no reference signal. I saw mixed messages regarding that on the forums, but we know now for sure that this particular 4-liter in 94, the tach should show around 200 RPM cranking if the reference sensor is working. Also, you'll get the initial fuel pump prime. But no rerun of the fuel pump after a cranking event. Just like a Chevy. So I'm curious as to whether or not he changed this coil. I'm waiting for him to call me, as I see a spare coil sitting on the floor. I decided to check the primary resistance, and it's 1.3 ohms, which I think is reasonable. I've got the igniter disconnected, so the white-black wire is isolated. I don't have to disconnect the coil. Yeah, if the coil was shorted, it could take out the igniter.